Hello everyone, today we're going to take a look how we can make our services more resilient using the Outbox pattern. So this tutorial is based on this article that I wrote and I'll share with you the link below after this video. So first of all, I've prepared the diagram to take a look at the types of architecture and what the problems are with microservices. So there are mainly two types of architecture, the monolith and the distributed. So the monolith is a single process and I think we are all familiar with it. So we have one big executable, one big solution with a lot of classes, libraries and whatnot in it. So it's deployed as a single unit. So like ASP.NET MVC or any other project that goes as a single solution. And you also have one big database that goes hand in hand with it. So here we have the catalog, ordering, inventory, search, reviews. All of these are inside this big single solution. The other approach is the distributed approach. This is a multiple process. We have many different services that go on different containers, different machines, and they all communicate usually through message bus. You could communicate with HTTP directly and wait for a response, but that's not desired. So we tend to use message bus and queues. So what's the problem? I mean, there are many problems with microservices and the distributed architecture. Well, being distributed comes with a lot of caveats like networking issues, latency, database consistency and whatnot. So for our purposes, first of all, let's see how both of these scale. So monoliths, they scale by just copying the whole thing, the whole solution, and deploying it on a different machine or container. While microservices, they are more granular. For example, let's say we have an e-commerce website and most of the times people are just browsing. So the biggest load here is on the catalog service. So we decided to go with 4 instances and 3 databases. Ordering, we're not receiving that many orders, so we could go with 2. And search, many people do search, so let's say 3 instances and 2 databases. Same for notifications, 2 instances, but here 1 database. And reviews, not so many people do reviews, so we're good to go with 1 instance. Again, we're using message bus here, which is okay. Now, what the problem is with the distributed approach? Well, one of the problems, there are many, but one of the problems that we'll take a look is what happens when the message bus, so the middleman that we use for communication, is down. So let's say Bob right here is creating a new order. He likes this MacBook and he creates an order. It goes to the ordering service. On the ordering service, implements its business logic, it creates the order, but then it needs to communicate with the notification service so that notification service can send emails, SMS and whatnot to the user to notify him that his order is ready to be shipped and whatever it is. Yeah, well, when message bus is down, we cannot do that. So we could either say to the user, well, we cannot serve you today, maybe try tomorrow, or, which is by the way terrible approach, we will use Bob forever. The other approach is the Outbox pattern. So let's see how we can handle this situation using the Outbox pattern. So here it is, the ordering service and the notification service. So the ordering service creates the new order in the order table, but then as part of the transaction creates a new entry in this table called Outbox. Then we have this order processor that queries this table and sends the entries that haven't been processed yet to the queue. So we have this middleman between the queue and our microservice. So in this case, the message bus is down, so it won't be able to do that. But when the message bus is up, our processor would query the table again and send the entries here. So the notification microservice can get those orders and send emails to the users. And this is happening automatically. So this creates really a resilient solution. Even if message bus is down, at some point it will go up and we will be able to continue where we left off, instead of saying to the user that he cannot create an order today, maybe try tomorrow, which is terrible. So now let's see how we can implement this in .NET. So now we're going to create a new solution and call it Outbox pattern. Okay, we're going to create two microservices, notification service and ordering service. Oh, we will use this. Okay, let's see, notification service. So make sure this is unclicked. We'll be using minimal APIs. Let's click on create. And the other one is ordering service. Okay. Again, minimal APIs. Now we need to install a few packages. Let's start with ordering service. We need to install RabbitMQ client because we'll be using that. We'll be using a RabbitMQ. Okay, let's install this. Apply. Okay, now we need to install another package, which is this one right here, because we'll be using SQLite for our database. Okay, let's install this. Okay, another package that we need is this one. Let's install this as well. We are good to go now. So now we need to install that same package to the notification service, the RabbitMQ client. Okay, we're good to go. Now let's start implementing our solution here. So we'll create a new folder. Let's call it, actually, let's call it orders. Now let's create a few entities. First of all, the first one is order, which is going to be a record. Okay. Second one is order outbox, which is this here. Now to create our DB context, let's name it ordering DB context. Okay, and here is our ordering DB context. So here are two entities. So these are DB context. Now what we need to do is create our service, which is order service, and here is our order service. So we have an interface for getting an order, getting our outbox, and creating an order. So the most important thing here is this creating an order. So here we are implementing the outbox pattern in action. So we're creating the order as part of a transaction, and we are also, as part of this same transaction, creating an outbox entry for that order, where we add the order, so the payload, and some metadata. And we save all that as a single transaction. Great, so let's save this. Now we need to create our processor, which is going to be responsible for processing the messages from the outbox table and sending them to the queue. Let's name this other outbox processor, and let's add this here. So the code is available on GitHub. I don't want to waste time writing this. So what we're doing here is every 20 seconds we are running this, and this tries to get all of the not processed entries in the Outbox table and send them to the queue and then mark them as processed. We'll see this in action. Okay, let's save this. Now we need to update our program CS and let's remove all this and add the following. We are adding the transient service, we are adding the context with the database for SQLite, we're adding the hosted service, and we created the three endpoints for posting a new order, getting an order by ID, and getting all the Outbox. Also, we are creating the scope for creating a new SQLite database, and that's really it. Now let's update this with the following. We'll be using this HTTP file later, and we're good to go with this. So let's now move on to our notification service. For that one, we need to create a new file, a new class, that is the processor. So order received processor, which will process so this our processor, which I kind of forgot to add, but let's say that is here, order received processor. So let's say this is handling that, and yeah, it's part of the notification service. Let's add the following. It's again a hosted service that will run every 10 seconds and will try to get the message from the queue, and when it does, it will say new order received, the message, so the payload from the order, and sending notification email to the user. We'll see that in action. Okay, now let's go to program CS. We'll clean it a bit, add the hosted service, and we're good to go. Now we need to create a new migration for ordering service. We need to make sure that we have the following installed, and we do. So now let's create a new migration. But not for the notification, but for order service. Okay. So here is our migrations table. Now we're good to go. Actually, one thing that's left is that we need to run a container instance of RabbitMQ, and to be able to do that, you need to run the following. And also make sure that if you're using Windows, you have Docker Desktop installed. For Linux, it's easier. So we have our RabbitMQ running, and now we need to run both of these services. So here we are inside the folders. Let's .NET run and .NET run here as well. So now we have both of our services running, the notification service and the ordering service. Now let's play around with this. First, let's go to the HTTP file and click on Outbox. So we see that it's empty because we don't have any orders yet. Let's now create a new order by clicking Post, and now we have a new order. Let's now go to the notification service and wait a few seconds. And now we received a new order, and we see that sending notification email to the user. So the communication between the order service and the notification service is working as expected. Now if we take a look at the Outbox, we'll see the entry there and processed as true, which is what we wanted. So now let's break things up. So let's test our resiliency. In order to do that, we need to stop RabbitMQ, so our middleman. Let's stop that. And now we're seen in action the following. So the RabbitMQ is down, so here as well. So now let's see how our system will handle that. Is it resilient enough to handle this? Let's create a new order with ID of 2 this time. And now let's send the request. So the order is created. So the user is happy. He was able to create an order. Now let's go to Outbox and see. So here is our second order. But this time the process says false, and it will stay that way until the RabbitMQ is up again. So let's take a look at the notification service. And what we see here is we're trying to connect to RabbitMQ. Our service is trying, but at this time it's not able to. So it's trying again and again, but it's not able to. Okay, so let's now run our RabbitMQ container again and see if something changes or not. Let's monitor a bit and wait. So as you see, we're trying to connect again. So the notification service tries to connect again. This time it's able to connect to RabbitMQ, and it received a new order with ID of 2, and it's sending a notification email to the user. So that means that our system is way more resilient now. It was able to handle this failure, and the user didn't even know that this happened. So he was able to create an order, received a new successful message saying that your MacBook is on your way, and yada yada, and he didn't even know that there were some system issues. And this is how it should happen, really, because the user shouldn't be aware of this. So our system was able to handle that gracefully, so it is resilient, and this is how the Outbox pattern can help you in situations like that and make your system more resilient and your customers happy. Thank you so much for watching, and I highly suggest you read the article from the beginning of this video. You'll find the link below, and thank you so much for watching.